So for this video, I will be teaching you how to solve for the equations of the tangents and normals to a given curve. Okay, so when we say tangent, so a tangent is a line intersecting a curve at a single point. So meaning, so it's a line that passes through the curve at one point only. Okay, so say for example, so we have here a Cartesian plane. Okay, and then we have here a curve. So say for example, so our curve is like that. Okay, so a tangent line is a line passing through the point or the curve at a single point. Okay, so this is called the tangent. Okay, so the tangent line, and then this is our curve, so described as y as a function of x. Okay, so by the way, this is our x-axis, and then this is our y-axis. Okay, so this is the tangent line. Okay, and we are asked to solve for the equations of those lines. Okay, tangent and normal lines. So by the way, the point of tangency, okay, which is this single point here, we can call it x1 and y1. Oops. Okay, so x1 and y1. Okay, and then the normal. Okay, so the normal line is a line perpendicular to the tangent line. Okay, also passing through the point of tangency. Okay, so this common point here, so this is the normal line. Okay, so in differential calculus, okay, so the derivative is very helpful because the derivative actually describes the slope of the tangent line at the point of tangency x1 and y1. Okay, so we have to take note, so according to the derivative, that the slope of the tangent line so let's call that mt. Okay, so the slope stands for m stands for the slope. So the slope of the tangent line, okay, is the f prime of x. Okay, so f prime of x, or the derivative, okay, at x1 and y1. Okay, so whenever we have a curve, okay, so if we are given a function, y is a function of x. Okay, so all we need to do is get the derivative dy over dx, or f prime of x. Okay, and then substitute the values for the points x1 and y1. Okay, so we will obtain there the value of the slope, okay, for the tangent line. Okay, so the points x1, y1 are usually given in the problem, but if it's not given, then usually the problem will give hints. Okay, so it will give hints, and it may require us to solve first the point of tangency. Okay, so given the conditions now of the problem, so we can also solve for the point of tangency. So the slope of the normal line, okay, so since they are perpendicular with each other, so the tangent and the normal lines are perpendicular with each other, so meaning the angle between them is 90 degrees. Okay, so from analytical geometry, so let us recall that when we have perpendicular lines, their slope is the negative reciprocal of the other. Okay, so therefore for the slope of the normal line, okay, let's call that m sub n. Okay, so the slope of the normal line is negative reciprocal of the slope of the tangent. Okay, so let us also review for the equation of the lines. So the most useful form I think that we're gonna be using is the point slope form. Okay, so point slope form of the equation of lines. So point slope, so meaning we are given with a point, obviously that is the point of tangency, and then the slope of the tangent line, which can be derived, which can be obtained from the derivative. Okay, so we are given the point, so we are given the point x1 and then y1, and we are given with a slope. Okay, so the point slope form is y minus y1 is equal to m x minus x1. Okay, so from there, this is a standard form, okay, of equation of lines, but for some problems I think we will be required to express the lines in general form. So general form of the lines is ax plus by plus c is equal to 0. Okay, so those are, I think, the things that we should remember. Okay, so let's try to solve some problems, so using this details what we have discussed here. Okay, so let's have this example. So example number 1. So find the equations of the normal and tangent at the point indicated. So we have the curve y is equal to 2 plus 4x minus x cubed, and then at point x is equal to negative 1. Okay, so for this problem, so we were only given the x coordinate of the point. The x coordinate of the point is negative 1. Okay, so we are not given with y. Okay, but we are given with the equation of the curve. Okay, so given x, we can also solve for y, right? Because x is equal to negative 1 is lies in this curve. So meaning if we substitute x is equal to negative 1 in x here, so we'll obtain the y coordinate of the point of tangency. Okay, so by the way, so it may for illustration purposes, so it may be good if we graph this. Okay, so for illustration, but actually we can solve these problems without graphing the curve. Okay, so solving for y. Okay, so for solution, so we solve first for y. Okay, at x is equal to negative 1. Okay, so because as you can see, we will be using the point slope form, to solve for the line, and the point should have a y coordinate. Okay, so remember the formula for the point slope form, it should have this one, so it should have y1, okay, and then x1. Okay, so the point, so we need to solve for y. Okay, so y is equal to, so all we need to do is substitute x is equal to negative 1 here. So you have 2 plus 4x minus x cubed, so that is equal to 2 plus 4 times negative 1 minus negative 1 cube. So that should give us 2 minus 4 plus 1. So that is negative 1, I think. Wait, I'll check using my calculator. But I think it's negative 1. Okay, I just don't trust my judgment. So para sure. So let's have calculator. So 2 plus 4 times negative 1 minus negative 1 cube. Oops, it's negative 3. Oops, sorry. It's because negative there. Yeah, I'm right. So it's negative 1. Okay, so the point of tangency, therefore, so the point is at negative 1, negative 1. Okay, so the next thing we're gonna do is to solve for the slope of the tangent. So solve for the slope of the tangent line. So earlier, as we have discussed, so the derivative describes the slope of the tangent line. Okay, so the slope of the tangent is equal to the derivative. So that means it's dy over dx, okay, at the described point. So at x is equal to negative 1 and y is equal to negative 1. Okay, so solving for the slope of the tangent, so we will derive the function. Now y is equal to 2 plus 4x minus x cubed. So take its derivative, okay, and then substitute for the values of x and y. The x is equal to negative 1 and y is equal to negative 1. So these two. Okay, so therefore, so deriving this, the derivative of constant 0 plus derivative of 4x, that is 4 times 1, okay, minus derivative of x cubed, that is 3x squared. Okay, so next is substitute the value for x. Okay, so we only have x here, so we will be using x is equal to negative 1. So this will become 4 minus 3 times x squared, so negative 1 squared. Okay, so the slope of the tangent now becomes, so 4 minus 3 times negative 1 squared, so negative 1 squared is positive 1 times 3, so this will be equal to 1. Okay, the slope is 1. Okay, so solving for the slope of the normal, so slope of the normal line is equal to negative reciprocal of the slope of the tangent line. So we will have negative 1 over slope of the tangent line is 1. So therefore, the slope of the normal line is negative 1. Okay, so now to solve for the equations, so for the tangent, so for the tangent line, so it is described by a slope of 1 and point negative 1, negative 1. Okay, so the point of tangency. So using the point slope form. So you have y minus y1 is equal to m times x minus x1. Substitute y1 is equal to negative 1, x1 is also equal to negative 1. Then y minus negative 1 is equal to, the slope of the tangent is 1 times x minus negative 1. Okay, so we will be using a bracket since we have parentheses inside. So simplifying, this is y plus 1 is equal to x plus 1. Okay, so transforming this into the general form, so we can cancel we can cancel 1. Okay, then transposing y the other side, so we'll have x minus y is equal to 0. Okay, so this is the equation of tangent. Okay, so next is for the normal line. Its slope is equal to negative 1, passing through the same point at negative 1, negative 1. Okay, so therefore, using the point slope form again, y minus y1 is equal to m times x minus x1. Okay, and then substituting. So y minus y1 is negative 1 is equal to m is negative 1, oops, x minus negative 1. Okay, so simplifying this will become y plus 1 is equal to negative, this will become x plus 1. Okay, and then distributing, so y plus 1 is equal to negative x minus 1. Okay, so transposing negative x and negative 1, so it will become x plus y plus 2 is equal to 0. So this is now the equation of our the normal line. Okay, so again, as I've said, so we don't necessarily need to graph, okay, the curve. Okay, but it will be a very good illustration if you can see how this curve looks like, okay, and how these lines look like, so the tangent and the normal lines. Okay, so maybe we can have that on another video. Okay, I'll be looking for graphing papers, okay, so that we can graph the curves. We can graph the curves. Okay.